Hey everyone, in this video I'm going to show you how to solve quadratics with inverse operations. But before we jump into that, we should talk carefully about what the inverse of squaring is. So first of all, if we look at the square root of 9, the square root of 9 is 3, and that's all that there is. That's what the square root of 9 is. But if we say that x squared equals 9, we'd be tempted to say that the inverse of squaring is square rooting, which means that x is 3. And that's actually incorrect. And the reason why it's incorrect is that there's actually two things that which squared can equal 9. 3 squared equals 9, but also negative 3 squared equals 9. So what we should actually be doing in this step, instead of just square rooting both sides, we should plus or minus square root both sides to show that. So in other words, if you have x squared equals 9, then x equals plus or minus root 9. So x equals plus or minus 3. And that's our way of showing that it could be positive 3 or negative 3. Okay, now that we've got that out of the way, let's do an actual solving quadratics question. Let's say we have 8x squared plus 11 equals 83. So this is the simplest type of quadratic equation we can have. It only has an x squared term and constants, which means that we can actually just use basically our grade 9 algebra skills plus this idea of plus or minus square roots to solve. So our first step, the positive 11 is going to become negative 11 on the other side. So 83 minus 11 is 72, and the 8x squared is just chilling on the left. And then the 8 we're going to divide by, so 72 divided by 8 is 9. And just like we had here, this is literally the exact same thing. We're now going to have x equals plus or minus square root 9, which means x is plus or minus 3. And that literally means, normally we wouldn't write this out, but that literally means that x equals negative 3 or x equals 3. Okay, so sometimes you can just solve them simply like that. Another way we can write this question is asking for the zeros of a function. So what are the zeros of f of x equals, let's do negative 5, x plus 3 squared plus 80. Okay, so first of all, the zeros literally means we want our function to equal 0. So what we really want is 0 equals our whole function. Negative 5, x plus 3 squared plus 80. Okay, now we just do our sort of regular algebra with the one extra step that I just showed you guys. The positive 80, when it moves to the other side, becomes negative 80, and everything else just stays the same. Now, this stuff's all inside the brackets, so the next thing we deal with is the negative 5. So the inverse of multiplying by negative 5 is dividing by negative 5. So we will divide by negative 5, divide by negative 5. So our left-hand side then, negative divided by negative is positive. 80 divided by 5 is 16. So 16 equals negative, oh, sorry, the negative 5 is done. What am I doing? That's what we just got rid of. Sorry, it helps to show you're canceling, so you don't make that mistake I just made there. Okay, so our right-hand side that we're left with is just the x plus 3 squared. So now in the inverse of squaring is going to be plus or minus square rooting. And so we're plus or minus square rooting the 16 in this case. And now our squared is gone, so we don't need the brackets anymore. So we're left with x plus 3. And our last step is to take our positive 3, move it to the other side. So it's negative 3 plus or minus root 16 equals x. And I usually like writing my variable on the left. X equals negative 3 plus or minus, and root 16 is 4. Now in this case we can actually evaluate this. So negative 3 plus or minus 4, maybe it's okay, but usually we would actually want to split this into our two different values. X equals negative 3 minus 4 would be negative 7, and negative 3 plus 4 would give us 1. And so those are the two x-intercepts. Those are the two zeros of our function. And I showed you in the last video, if you wanted, you could now average those two to find the axis of symmetry, substitute that back into your original equation to find your vertex. This example is very similar, except that we aren't going to get nice integer values in the end. So I'm going to show you guys how to show the exact value in radical form, so that's with square roots, or how to plug it into a calculator to get your decimal values. So again, we want the zeros of this function. So we want 0 equals 3x minus 5 squared minus 45. So the 45 is going to become positive 45 when we bring it to the other side. We're going to divide by 3, which makes it 15. And then we have our x minus 5 squared. So now in this case, the inverse of squaring is, or the opposite of squaring, I guess, is going to be plus or minus square rooting. But we can't actually square root 15. 15 is not a perfect square. In fact, it's 3 times 5. So those are, we can't reduce that at all. So all that we have left to do is bring the 5 to the other side. I'm just going to skip to doing the x on the left-hand side to save a bit of space. So the negative 5 becomes positive 5 in front, plus or minus root 15. And so that is your exact answer. And most teachers are okay with it in that form. Sometimes you might be asked to split it into your two values, x equals 5 minus root 15, and x equals 5 plus root 15. But usually you just keep this answer that's in the box right here. That's usually fine. Now, if you wanted the exact answer, or sorry, the decimal answer, what you would need to do then is just one more step. You plug root 15 into your calculator, and you get 3.87. So this is x equals 5 minus 3.87, x equals 5 plus 3.87. And with decimal values, you usually don't want to keep it in this sort of plus or minus form. You usually do want to split it into your two answers. So x equals, so 5 minus that's going to be 1.13, and 5 plus that is going to be 8.87. So your decimal answer is those two. So this is your decimal, and this is your exact. And so depending what the question asks for, the exact one or the decimal answer, that's what it's expecting.